Hello everyone. In this short video, I'm going to show you how to take a logic circuit on a paper and implement it on a breadboard. Here, as you can see in the first sheet, we have a truth table. From that, a logic function, and logic function derived into a logic circuit. So let's look here. Very first thing I would say is mark the gates, each gate by a number. So I'm going to call this gate 1, my AND gate as gate 2, and my OR gate as gate 3. And make sure each and every input and output has a wire name. So for example, look at this NAND gate. Both the inputs are connected to A and the output does not have a name. So I'm going to call this node 1. And come to gate 2, both the inputs have a name, N1 and B. The output does not have a name. I'm going to call this N2. Come to the gate 3. Now we have N2 as one input, the second input as A, the output is F. So the labels are all given there. Now, in order to implement this on a breadboard, we need an NAND gate for gate 1, and the NAND gate is given here. We get a quadruple 2-input NAND gate. So in here we have 4 NAND gates, and we can pick and choose only one of them. And the second gate we need is an AND gate, which is the second logic circuit diagram I've shown you here in the center. And the third one is an OR gate. So the first one is an NAND, the second is an AND gate, and the third is an OR gate. So here we need one gate in each, right? So I'm going to use gate 1 of the NAND gate here, and the second gate I need is an AND gate. So I'm going to mark this as the gate 2 I'm going to use, and the third gate I need is an OR gate. So I'm going to pick one at random here. I'm going to pick that. So essentially what we have are 3 logic circuits. One is NAND, and an OR. Now we need to implement that on a breadboard. So on the second page here, what you see here is a typical layout of a breadboard you might see in the lab. And the top connections are wires, connectors to give you 5 volts and ground, which is in the black. And then there are different slots, different holes for the breadboard here. Now one thing I did is, if you notice, I took the red wire here, which is in pink, the pink wire connected to the red line, and as you can remember, the breadboard, the holes here, the holes in the bus layout here are all connected vertically down, and the holes in the breadboard slots, in the connection slots here, are connected horizontally across. So anything you connect probably in one of the holes here is available all the down here, right? That is the key point you have to remember. Now with this, the other point I want you guys to see is all the ICs on the page 1. If you look at the top right pin, it has VCC, VCC, and VCC, right? Similarly, the bottom left pin has ground, and has ground. So I took all of them, like all these are grounds, right? So I connected, as you can see, pin 7 from the third IC, from pin 7 from the second IC, and pins 7 from the first IC are all connected to ground. So let's say the first one is our NAND gate, and the second one is our AND gate, and the third one is our OR gate. So I placed like 3 of them separately, a little far apart. Now let's see here. My input A on the logic circuit, both the inputs are connected to what pin here? And look at the NAND circuit here, pin 1 and pin 2, right? Pin 1 and pin 2 should be connected together. So what I'm going to do now is I'm going to take a wire and look at pin 1 here, pin 1, I'm going to connect it to pin 2 through a simple wire here. Okay, that makes my first and second pin connected together. Now I'm going to take the output, which is pin 3. See here, my output of the NAND gate is going into input of the AND gate. So for example, we are saying this output has to come down and go as input to pin 1 here, right? Now I'm going to take this pin 3 and mark it, take a wire and plug it all the way to pin 1. So if I do that, I'm connecting the output of my NAND gate to input of the AND gate. Now the second input of the AND gate is connected to input B. So on the schematic, on the pin configuration in the page 1, if you see, I have B1 is connected to pin 2. So I'm going to take my input from the external and put a wire here to B, and I'm going to give my input B here later on. Now look at the output of the AND gate. The output of the AND gate is going into input of the OR gate. So in the center schematic, I have my AND gate. I'm going to take this output and connect it to pin 1 of the OR gate. So in other words, pin 3 of my AND gate is going into pin 1 of the OR gate. So similarly, I'm going to take pin 3 here. I'm going to take pin 3 and connect it all the way to pin 1. So if I take a wire, connect the output of pin 3 to input of pin 1 here, we are making this connection here. Now the next thing I need to do is I need to take my second input and connect it to my input A. And as you can see, this input A is connected at, this is my input A at the first input. So I'm going to take my second input of the OR gate and connect it to the input 1 of the first NAND gate. So I'm going to come down to my OR gate here, and I'm going to take this connection, sorry about that disappearing here. So I'm going to take the second input of the OR gate and draw a wire from there, or take a wire and connect it all the way to there. So I make that connection, and now I would have a wire flowing from input 1 of the NAND gate to input 2 of the OR gate. Okay, now the next thing I need to do is take this and connect it to a simple resistor, connect it to an LED and ground it. So the way we do it is, the output is pin 3, right? So what I'm going to do now is I'm going to take output 3, take a wire, go all the way onto this side, connect in one place, and take a resistor from on the side connection here, take a resistor and connect a resistor to somewhere in the next hole here, and from there take an LED. I'm going to show you that in the class, but take an LED and connect the output to ground. With that, you can complete your logic circuit. And I know it is a little confusing, but I want you to understand how to insert the integrated circuits on a breadboard and how to use a schematic to implement that on a hands-on breadboard. We will talk more about this when we meet in the class. Thank you.